Our objectives for this video is 1. Define Newton's third law of motion, and 2. Describe action, force, and reaction force, and how they relate to Newton's third law. So to start, Newton's third law, basically for every action force, there is an equal and opposite reaction force. So anytime a force is applied to an object, that same force is applied backwards, right? Opposite directions. So if we push on a wall with 20 newtons, our action force, pushing up against a wall of 20 newtons, the reaction force of the wall to my action force is 20 newtons back. However, unlike pushing up against the wall where we know I'm not going to make the object move, force pairs do not act on the same object. Taking a look at this swimmer here in the water, the action force is the swimming hand pushing on the water. Okay? Swimmer's taking the swim in. The action force is the hand pushing on the water, pulling it backwards. The reaction force is the water pushing on the hand. The reaction force moves the swimmer forward. So even though my action is the one pulling the water down, the reaction force of the water pushing back on my hand is what actually propels the swimmer forward. All forces act in pairs. Again, it's equal but opposite, but there's always two forces acting as a pair, one against each other. For instance, a shuttle taking off going into outer space. The gases push downward from the shuttle, say it's 60 newtons, even though it's way bigger than that. The gases then push the shuttle upward. Okay, there's our reaction force of 60 newtons. Okay. However, the gases, like we saw before with the swimming, actually is what propel the space shuttle into outer space. If we take a look over here, the bat, the action force of the ball going into the bat, okay, causes a reaction force of the bat to the ball, therefore sending the ball farther because of the more force applied by the swinger of the bat. So now what I want you to do is I want you to try and apply Newton's third law. How does a rabbit hop? Use Newton's third law to explain action and reaction forces of the movement of the rabbit. Take a look back at the video, at the other screens, to figure out where the action-reaction takes part. Remember that rabbit's in motion, so think about where that action-reaction is taking place.